Hello, everybody. My name is Kapil Arora. I am a field agricultural engineer with Iowa State University Extension and Outreach. And with me today is Sean Schaus. We are actually going to tag team this presentation. Sean is also a field ag engineer in Southwest Iowa. He covers that part of the region while I cover central Iowa area. Today, we are going to be talking to you about grain storage replacement decisions that we have to do and the planning that goes around managing and handling grain at those sites. The overall objective here today, folks, is basically as we are figuring out if we are doing any repairing or replacement on these facilities, what are the questions we need to walk through to make sure our grain handling efficiencies are improved. We're going to be asking you folks to consider some of the questions that go around in this process. We want to end up in a situation so that we are moving forward, our facilities are improved, and it fits in better with your harvesting logistics. Also, we're going to touch base on some of the expansion questions that we may need you to consider. And then we'll finish off later on with discussing grain storage. That's what we are dealing with here today with the 2020 grain harvest that just finished up here about a month ago. This year in Iowa, we had the derecho storm that went through almost from our west border all the way across through the east border, which caused a lot of damage. But other years, we also deal with fire. We also deal with straight line winds, which end up causing damage to our grain storage and handling facilities. We have seen buckled bins. We have seen bins with tops sheared off, or the bins are moved off of their foundations. We have seen things where dryers are burnt. We also see auger and flighting damage. We also see issues with the foundation where, especially with the straight line winds, if that's an empty bin, it's just moved off the foundation, but in doing so, all the anchor bolts are pulled off. Or otherwise, also, if the site is not suitable, maybe there's foundation sinking or unevenness there. So, things, there are questions that do come around in these grain facilities handling. So, as we are getting into fixing or making decisions about maybe even replacing these damaged facilities, we typically do get our insurance involved, and they give us a check for whatever adjustments they do and whatever money we get from them. But once you have that part of the equation done from damage, the next thing to decide for is should you even consider replacing or should you just repair? And if the question is to replace, then also to consider things alongside our uh, is that site suitable where you already had the facilities? Is that site okay with the logistics of grain harvest that you are dealing with? Is it issues there, or are there bottlenecks where things get held up? At the same time, are the sizes okay? Do you have enough drying capacity, or your dump pits about this size that it can handle the flow of grain? And then also looking into the future, what kind of expansion that you might be faced with. And then after we get done with that part, then I'll hand it over to my counterpart, Sean Schaus here, and he'll take us through the rest of the presentation on managing this year's crop and then other additional resources that are available to us. So first and foremost, once you get that check come in from the damage, question then pops right up is, should you replace or should you actually repair? Thumb rule to use there, very easy, is if you're going to spend more than half the money or half the cost, what it is going to cost you to replace the facility in repairs itself, then it's better actually to see if you can actually replace it. If you're spending that kind of money, you need to consider the life on that uh, bin or that dryer into that all equation. And if you're spending already too much money, then it may be thing to just replace. And then while you have made that part to decide whether you're doing repairs or replacement, uh, the extent of repairs that you may do may also come into question as to answering the rest of the questions that are listed here in front of you. Basically, is this location giving you problems in the previous years? Is the equipment okay to move around this facility? Site wise, are there any soils issues here, or are there any water table or drainage issues? Then also, is the size okay, or are you basically looking at maybe doing some repairs now and then replacing down the line? And then, if there are expansions planned, you're thinking of maybe bringing in more acres, or one of your kids is coming back to the farm and he or she is looking at maybe putting in more acres into your farming operation. So, how all that plays out hand in hand becomes very important. So, as we are looking through these questions, the things to really look for the site part is how central is it to your entire harvest operation? Uh, are you kind of in the middle, or how much travel time are you spending? Is this particular site has enough surface drainage so there is no issue for um, equipment, grain carts moving in and out? You're looking at a picture there where the grain bin got sheared off due to derecho. But is this the site where to put the new bin back up? Are there any soils issues for foundations, water table issues? What kind of access do you have to the roads? Also, if you're going to put motors on there for fans, especially, or other large electrical equipment, do you have good utility service available? And then we'll also touch base quickly on the safety aspect of things. This is an important piece to enjoying a good quality of life on the farmstead, and just making sure everybody in the family and the neighbors are all safe. So here, looking through the location of the grain handling system itself, the picture there on the right that I'm showing you just has storage bins there. So it's only a storage facility, but the question would be, is it a central storage location or is it a satellite location? If it is a satellite location, then maybe you're not thinking much about bringing any drying there. But if it is on the other side a hub, then are we talking about adding dryers, dump it, or what sizes you already have them, or is that a expansion you want to plan into? And if that is an expansion you are looking into, then spending the money for that expansion becomes a very important question to sizing things accordingly. We are wanting to make sure the site actually maximizes your grain movement, whether you're bringing it in on carts or on trucks. It supports that central piece. So, handling it in both situations and walking through those questions becomes very important. As you look at the site itself, other than the transportation and efficiency part of it, the footprint on which the site sits by itself also is important because it plays an important role into that efficiency. So what we are talking about here is uh, almost divided into two parts. One is the site access. So when the grain is moving at harvest time, and other times when you are moving it off the site, if you are selling it, does the site tend towards making those operations successful? Then the other part that the site has to do is just store grain in the bins. These bins need to stay put. There is a lot of load in the bins itself. So the soils that are supporting those foundations just need to have good bearing capacity. That's some things to check for. Also, the site for the part of just storing grain also needs to make sure we're not dealing with any high water table issues, because in those situations then you can be dealing with settling foundations, which can again cause the loadings on those bins to shift and become uneven, and that can result in problems. The picture you are seeing here on the right, on the north side of those bends, you can see kind of a draw leading down into the grass waterway. It's not gonna serve very well to maybe put even a road around there, or even have any additional facilities put there, but it makes sure that all the surface drainage is draining away. Nothing is ponding there. We don't want to be in those situations. Maybe the area there can serve good for pushing the snow and moving it out of the way of the storage facilities. But those are the things to consider as as we are looking and evaluating the site itself for future expansions. Another question that comes along with this is, okay, we looked at the site for accessibility and its storage, but then also what is the access from the site outwards towards the road, because we'll be bringing grain in at harvest times from other fields. We'll be using the roads to enter back in. And during other times of the year, we are taking grain off of these facilities and moving it either to the elevator or to the feed mill. We are basically selling it and shipping it offsite. So having a vertical straight access 90-degree to the road comes in handy, because at the 90-degree um, shot, you are able to see clearly both left and right. You almost need about 600 feet of good visibility on either direction if you are entering into a highway that's got 50 to 60 mile per hour vehicles moving on it. That's almost needed so you can easily time yourself getting onto the road. Hard surface access or gravel roads are important because you'll be bringing those carts in fully loaded, so there's quite a bit of weight that moves in and out. So it becomes important to have good access at the site where your most grain movement is going to happen. Then also look for some of the things for future. If you're going to put an office there, maybe even have a bathroom or a restroom there. So do you have good water supply, good septic accessibility there that you can put up? And as far as electrical requirements go, all the equipment, fans, other motors over 10 horse that are running, they typically need three-phase power. So if you have three-phase power at the site, that will tend itself very well into your operation. If you only have single phase, you may be able to use some phase converters that convert that single phase over into three phase. But those are the things to watch for as you are doing your future expansion on those sites. Quickly, then, next thing that we're going to talk about is site evaluation from a safety standpoint. Sometimes this gets put on the back burner because we are wanting to maximize our efficiency for our farming operations. And sometimes we don't want to take land out of production and dedicate it to some of these things. Uh, but these are important features. They come into the quality of life you enjoy, especially if your hub is just next to your home on the farmstead. Then how do you maintain traffic for your family members so that you're not running into the farm traffic itself that you are bringing onto the farmstead? Also, as those motors are running, as the dryers are running, equipment moving in and out, you will have noise, you'll have dust. So those things will come into play, and it goes into the quality of life that you enjoy out there. So keeping things separated out enough, uh, having enough separation distance can make a difference there for yourself, and also if your hub is close to one of your neighbors. So those things can come in handy, and answering those questions now is kind of important as you go through this process of the decision making. Also, as we are moving forward, we are getting bigger and bigger bins. Security also becomes into question. Some of these newer facilities have quite a bit of sensors on them. So, are some of those sensors on the internet itself that you can look them up from anywhere? So, that forces you to have internet access at the site where the bins are itself. And if it is a satellite location, maybe you even have a few security cameras there. And again, being able to look up on your iPad at home, or on a tablet, or even on your smartphone, how the site is looking through those cameras. Again, need internet access to be able to do those things. Once you have evaluated the site itself, then the next thing to look at, and I'll say this is from a 30,000 feet elevation looking down at your operation. The whole idea here is to evaluate how, where everything is on your um, operation, how it fits into the logistics of your harvest, how quickly things move, how easily grain flows throughout your system, and are there any bottlenecks to that grain flow? And we have listed quite a few of them here: drying rate, wet holding capacity. Are your conveyors quick enough, fast enough to move grain from one place to the other? Is your receiving rate quick enough? And then can you handle all the traffic at that particular site? Or are there bottlenecks developing in just dumping the grain and the next cart shows up? And then, yes, we have gone through looking through those things, but would you even have those accessibilities during bad weather? Um, Sometimes we need to move things quicker. Sometimes we push things, we continue harvest during some of the inclement weather. It may not be as bad, but still, is the site accessible during those times? And we're going to take a few minutes and go through some of these in our equipment sizing part of the detail. Uh, as these bottlenecks are there, uh, and you have identified them, the right way to look at them and fix them is making sure we have the right size uh, planned out. So we'll first look at just the grain harvest from the field and coming to your hub where you are dumping it for drying or for storage. Just looking at, is the harvest rate matched up with the vehicles that are transporting, the size of the grain carts you have, and those coming in and dumping that grain into the receiving pit. Are those matched up so that uh, we are not waiting on one activity getting done before the next part of the operation can take over? And from that receiving pit, we are also talking about the unloading conveyor capacity, because how quickly that conveyor moves is how quickly the receiving pit will be empty, and that'll then define how quickly the grain carts can dump into it. So it's a gyration there of mind in those capacities and rates that you have to work through. We do have some help available through some of our handbooks. We do have Midwest Plant Service handbook on grain handling facilities that can actually walk you through some of these questions relatively easily. Plus, we have our field engineers also available who can help you. All right. So one of the things to watch for is the drying capacity, because that can be a bottleneck. The drying capacity on the dryer sometimes is can be a mismatch. If it is too quick, then the receiving pit will get empty too quickly. Otherwise, if it is too slow, the receiving pit will not get emptied out quick enough, and then you can't really dump the next load. So here, the things to watch for is what's your maximum daily harvest capacity, what kind of drying system you have put in place, and what is the amount of automation that is in place to move that grain without you being there, without you physically moving things around or turning things on and off. And then how many hours can you run the facility even after when the harvest has stopped? Can you make use of the time when the equipment is down or due to bad weather we're not running the harvest? So can we make those efficiencies um, better by taking advantage of some of the downtime that exists? Uh, Drying capacity, I'm just gonna look at it from a little different way. Uh, Even if you don't have enough drying capacity, don't just make the decision that you need a bigger dryer. You may be looking at maybe getting off just as well, but by putting in more wet holding capacity. Uh, Basically, all you are doing is, yes, the grain coming from the field is at a harvest rate faster than what the dryer can handle, but it's just like a surge tank that can help you by putting in that wet holding bin where the wet grain coming off the field can be stored for short period of time that can then feed into the dryer. And this can serve out very well at the end of the day where harvest has stopped, but you still have full bin on the wet holding side that can then serve into the dryer and make use of the efficiency of the time when you are down, not harvesting, and things are still working through. Uh, on the wet holding side, we got to make sure we put in enough aeration in there. The grain is hot and it has the potential to go bad or start going bad if we don't put proper aeration on it. Regular floor aeration or aeration through ducts can help out. Uh, on the type of the bin itself for wet holding, hopper bottom bins may be the best ideal for it because we want everything to kind of drain out. But we can also use cylindrical bins there. And if we got an inverted cone in it of dry grain, that can basically serve the purpose of a wet holding bin itself. Now, how big the wet holding bin or the wet holding capacity needs to be, we need to figure this out on the basis of, okay, what is our daily harvest capacity? How many acres or how many bushels per hour we are bringing in from the field? And then what is our drying capacity for the same time duration? How many bushels we are able to dry out? Subtract those two numbers out and then increase it by at least 50% because you just don't know how those surges will happen. So you want to be able to accommodate for ups and downs that may happen during your drying operation itself. As far as the aeration on this wet holding bin, the recommendation is to have at least half a CFM per bushel going through there. It's just to make sure we don't get into any moisture accumulation issues. That way, everything stays handy and we are able to move things through. The next thing to look into when we are doing the sizing here, we don't want to be stuck in a situation where our dump pit is okay, receiving pit has the right capacity, our wet holding has the right capacity. Now we have matched up our dryer also, but our conveyors are not able to feed from one location to the next one okay. The things to watch here are if we are running in batches, then we need to size our conveyors for higher capacities so we can move quickly and move that grain fast and we are not waiting on things to happen. That will be really helpful. If we are in continuous flow or if we have systems with surge tanks, then having a little bit lower capacity on these conveyors can be okay. Another thing to watch for on these conveyors is as you go from the receiving pit to the dryer, you have a conveyor with one capacity, but then from the dryer to the cooling bin, the next conveyor needs to be at a higher capacity. And our typical recommendation there is having at least 10 to 15% more uh, capacity to be able to move things. We don't want to size them up too much so that they are only running at partial capacity, especially pneumatic conveyors, screw conveyors. If we run them on partial capacities, they can actually reduce efficiency and also cause grain damage, which results in poor quality on the grain. So we don't want to be too much oversized, but be watchful on making sure things are moving efficiently all along here. Uh, the next thing that comes into play in doing the evaluation is do we have enough site access to be able to bring grain in or move grain off site? Uh, Even if you only have tractors and wagons, the thing to think for is if the tractor is down and you can't get the wagon in, you may be asking help from your neighbor, and neighbor's only got a truck. So plan out for the facilities to have maximum access for the largest size equipment that may show up, and without having to back up, without having to push things into other places or getting stuck in mud off the road. They're right at the facility itself, or if there is snow piled up, backed up into that snow, those things will not be favorable. So just making sure there's enough access for the largest piece of equipment, uh, and I'll just go for the 53-footer truck there because you want to be able to make sure you have access all the time to be able to move grain when you want to move it. The next part then is thinking about expansion. So we have gone so far through deciding whether to replace, doing evaluation on the site itself, then walking through some of the bottlenecks, and then also looking at sizing the equipment. But this part here deals with okay, where will you be in the next 3 to 5 years? If you are definitely looking at expansion, then doubling your capacity now and planning for it would be the right way to go. We got a couple graphs here for you to look at. The left one here is showing you what the yield in bushels per acre has been for Iowa in comparison to the US. The blue line there is Iowa, and we are on the up and up and actually going higher every year on bushels per acre. So we are increasing our overall production per acre. On the right hand side there, the graph there shows how many number of farms are there in the US. That is the blue line there. So the number of farms year over year has been declining. And since those numbers have been going up, the tillable acres have been picked up by other remaining farms. So the size of the farms that are in operation has been going up. What does that mean? Is we have more acres and more production per acre happening, which in other words basically is saying we need larger and larger facilities to manage the future expansion that we are dealing with. One way to look for this future expansion as we are doing it is to make sure we have good drying system that does not impact our grain quality. Uh, Managing grain in a 20,000 bushel bin is different than managing grain in a 100,000 bushel bin. Larger bins require more management just to make sure we got good quality grain to sell at the end when we are wanting to sell it. So our handling equipment, augers, conveyors need to be proper. We also need to make sure we build in cleaning options so we can get rid of damaged grain, fines that are in the system itself. That way, we assure we have good quality when we are running and operating these facilities. We also need to pay very good and close attention to our aeration also. Uh, as we store grain in these large and large bins, we just got to make sure we are able to properly aerate them. I know several of these bins are now coming with a lot more sensors in them, but again, making sure that we just have good aeration to keep the grain at good temperatures, get that moisture moved away and out of the bins, and have it equilibrium at equilibrium. All those things just go hand in hand to have good grain quality at the end. One other thing that I'll point out is as we plan for these expansions, we also need to plan safety into it. As we get into bigger bins, we get into the issue of okay, how do we get around making repairs? We don't want to be stringing ladders out there and then just climbing them up. We want to be able to bring in maintenance equipment and have space for that equipment to move around, not get stuck around in power lines. So just making sure the things are kind of spaced enough. Then the bins itself having railings, stairs, landings, all those things for your personal safety also. All the power lines that are there, all the connections are all sealed up, locked out, tagged out, so nobody is just going around doing anything. And then just having things posted, hazards marked are also important. These may look like things not not needing attention, but on the other side, safety should be top priority, and these things are important. These things all go hand in hand for grain quality management. We want to be, in the end, having good quality of grain. We don't want caked up grain in the bins or bridged grain uh, because all those things then become safety hazards. We don't want mold grain either because that's just money that's out of our pocket. So we want to play things safe and have good functional system. If expansion is definitely that you need to be considering, then one thing to quickly look for is just take a piece of paper and draw things out on it. Draw things out on it in your way of thinking how you will run the equipment from the field through this location where the bins will be that will get the grain from the dryer. Where will your receiving pit be, where you'll be easily able to come in and drop it off, where the road access will lie. Walk through this drawing in your head and draw things out, and this will help you figure out okay, what kind of conveyors are, where they'll be located, where your cooling bins will be, where will you'll have fuel for storage. uh, just putting it on piece of paper will help you visualize, and it'll actually be very helpful to you. You'll be really surprised. And once you are happy with what you got on a piece of paper as a rough drawing, then I'll say go in and draw it out to scale. And what this does is it puts things into proportion to make sure that things are the way the footprint will be out there on the field itself, and include your foundation sizes also in there. This will help you kind of draw it out to the best that you will be able to do out there. Going through this exercise now will help you save all the time, and then you don't have to go back and say, okay, I wish I had moved that bin maybe 10 feet more farther to the east so that my grain carts would have a better access around them. So those questions can get answered here when you are able to draw it to scale. You can evaluate your plan with others in your family, or you can actually even ask us for help. We got field engineers in extension that serve the entire state. You can contact your local county extension office, and we'll have resources available to you at the end of this presentation. Grain bin companies are also out there that can help you bounce off ideas. We have a list of them also available that you can contact, and we're not endorsing any one of them, but that list is available if you need it. And with that, I'm actually going to pass it on to my counterpart, Sean Schaus, who will take over, and he'll talk about the 2020 grain that's in storage and things to do for managing and handling it.
Thanks, Kapil. That was a great summary of the points to consider when you're evaluating a site and thinking about repair or replacement. We want to finish here just with a few words on storing the 2020 grain situation here. This year was a little different, as everybody knows, and so just a little extra advice here. We'll talk a little bit about controlling mold growth. We'll talk about temperature control during storage, because that's key to managing the grain in storage. We'll talk about aeration rates for cooling grain and keeping it cool. And we'll mention coring bins and then monitoring and safety to finish up. So the key points on this slide are, when you've got grain in storage, two things that are critical are the moisture content of the grain and the temperature of the grain. The reason for that is that the temperature influences both insect activity and mold growth in the grain, and the moisture content of the grain will then drive what the relative humidity of the air is between the kernels of grain. That makes a difference because mold growth is very sensitive to relative humidity. So that's why moisture content drives mold growth potential in the grain bin. We want to aerate to cool the grain. Why? Because cooling the grain gives you the ideal storage conditions to minimize mold and insect activity. Then we want to maintain even temperatures throughout the bin as long as it is in storage, to make sure that the conditions don't start to get worse after the grain is in the bin. Adequate aeration requires about 1/10 of a CFM per bushel for temperature control only, so that's kind of the minimum recommendation for aeration rate in storage bins. The way we do this is by running a cooling cycle through the bin every time the outdoor air temperature is 10 to 15 degrees cooler than the grain condition. We repeat those cooling cycles until the grain temperature is down in the range of 35 to 40 degrees for Iowa storage. Airflow rate is key to proper aeration and cooling. You can estimate the number of cooling hours to get a cooling front through the bin by dividing 15 by your airflow rate in CFM per bushel. So for example, if you've got a large drying fan on the bin that can deliver 1 cubic foot per minute per bushel of airflow, 15 divided by 1 would estimate about 15 hours to get a cooling front through the bin with that fan. If, on the other hand, you've just got a small aeration fan that delivers about 1/10 of a CFM per bushel, 15 divided by 1/10 would give you roughly 150 hours, or about 6 days to get a cooling front through the bin with that smaller aeration fan. So how do we manage this throughout the year? In the fall, we want to lower the grain temperature stepwise in 10 to 15 degree steps until we get the grain temperature down below 35 to 40 degrees. In the wintertime, we just want to maintain that low temperature, 35 to 40 degrees in the grain, with intermittent aeration as needed anytime the grain temperature starts to rise. In the spring, there's no need to warm the grain back up. We want to keep that grain cool through spring and summer storage. To do that, we will check it frequently, seal the fans when they're not operating to make sure warm air doesn't get in underneath the floor and rise up through the grain, and ventilate the head space above the grain between the grain surface and the roof of the bin to stop some of that surface warming that can happen from solar gain on the bin roof and warm air up in that head space. If you don't know the airflow rate in your bin, you can estimate that with a program that's available from the University of Minnesota. You can see the website there for that FANS program. This is an online estimating tool. You can use this in two different ways. You start by putting in the type of grain, the type of aeration system, and the bin dimensions and grain depth. You can put in a desired airflow rate, as we did here in this example, at 0.5 CFM per bushel. And then the program will estimate for you the bin capacity, the total airflow that you would be looking for to get that CFM rate per bushel, the estimated static pressure that the fan would have to work against to drive the airflow rate through the grain, and it will estimate for you the fan horsepower requirement to get that airflow rate per bushel. Another way to use this same program then is you can select a particular fan or number of fans from a large list on a drop-down menu, tell the program which fan you want to have installed on that bin, and then the program will estimate for you at different depths of grain what the airflow rate is, and it will calculate for you that airflow rate in CFM per bushel, so you can compare that to your target CFM per bushel. I want to mention coring the bin because this has a number of benefits for quality storage of grain. When you fill the bin with grain, the highest quality kernels, the best seed coat kernels, are slick and whole and tend to slide to the outside edges of the bin. The damaged kernels and fines tend to stay at the center of the bin in what we call the core of the pile of grain as the grain bin is filled. This works against you in a number of ways. Number one, the depth of grain right there at the center of the bin is highest, which means it's hardest to push airflow through the deeper part of the grain. And those broken kernels and fines are much harder to push air through than the whole high-quality kernels closer to the outside of the bin. These factors combined mean it's really hard to get good airflow rate up through that grain, and that grain with broken kernels and fines is more easily attacked by mold and insects, and so problems typically will show up in the center of the bin near the top when we do have grain storage quality issues in stored grain. Coring the bin can help in a number of ways. As you start to remove grain from the bottom unloading sump in the center of the bin, the first grain out comes right down the center of the bin from the top down through that core to the unloading sump. By coring the bin, we now have a number of better situations. The grain depth in the center of the bin is closer to the grain depth at the outside of the bin. We get a more uniform grain depth, which helps with uniform airflow. We've also removed some of the most vulnerable grain, that which is attacked most easily by insects and mold, so that's out of the bin. Now when we go to aerate the rest of this bin, we'll get much more uniform airflow with some of the highest risk grain already removed. So coring the bin is an excellent management idea just to make sure that you can keep that grain in best quality and get the best aeration of the grain in the bin. Monitoring 2020 grain will be critical. We want to control the temperature to around 35 degrees for that grain this winter. Check the grain every 1 to 2 weeks to make sure the condition is staying where you want it. And use caution when entering bins. There are safety issues there, and we'll talk about those in a minute. And have a plan for moving the grain if any problems start to develop in the grain bin. It's good to have a plan ahead of time so that you don't have to take time making calls and trying to decide what decisions should be made. For 2020 grain that wasn't fully dried at 15 to 18% moisture, I would say you, again, want to control the temperature to around 35 degrees. Check this grain at least weekly because it's a little wetter, and then finish drying this grain or move it before mid-spring. This grain may store well if you monitor it closely and keep it cool, but warmer spring temperatures will return, and then the grain, as it starts to warm up, will resume molding and spoiling at this higher moisture content. With normal grain, an average year, we would have said 15 to 20% moisture here, but with some grain quality problems that we had this year, I would say 15 to 18%. If you have any 2020 grain that was above 18% in the bin, I would say control the temperature again to around 35 degrees, and then market or move this grain to drying facilities as soon as that's possible. The risk of storing this grain even cool is high. I would not try to keep this grain through the winter without drying it or marketing it. When we monitor grain, one thing you can look for is the odor, the smell of the air coming out of the grain. If that air has a musty or a sour smell, it indicates that mold growth has begun somewhere in the grain mass, and that would indicate problems somewhere down below the surface of the grain. You need to smell the first flush of air that comes out of the grain bin. With a large drying fan, that first flush of air may come out in 30 seconds or so it might take two people, one up at the surface of the grain to smell the air and a second person to turn the fan on. With a larger or with a smaller aeration fan, you'll have several minutes to get that first flush of air out, and you can have a little more time for checking the smell of that air. Another thing to monitor would be the temperature. A temperature increase in the grain indicates that mold or insect activity has begun. You can do that with a portable temperature probe or with temperature cables that hang in the bin continuously that can be monitored remotely. You can probe the grain surface for sticky spots or heat, but one thing to keep in mind is you're probing the grain for either temperature or for sticky spots. Grain is a good insulator, so the temperature that you are measuring will be reflective of the area within a foot or two of that temperature sensor, but doesn't tell you much about grain farther away from the temperature sensor than that. A better option is to monitor the carbon dioxide level of the air coming out of the grain. CO2 concentration is an even better indicator than odor of the air coming out of the grain when you're looking for mold growth. Under 600 parts per million of CO2 concentration would indicate that conditions in the grain are good. If the CO2 concentration is between 600 and 1500 parts per million and increasing from one check to the next, that indicates that a problem is starting to develop somewhere in the bin. And if it is over 1500 parts per million, there's a serious problem somewhere in that grain mass, and it indicates that you should be moving that grain in a fairly soon fashion. Background concentration of CO2 in the air is around 400 parts per million, so these are all above background concentrations. To manage grain well, you need to know two things. You need to know the moisture and temperature of the grain in the bin. You should also consider the test weight of that grain, because lower test weight grain is more easily attacked by mold and insects and will not store as well as high test weight grain. The allowable storage time and how much you've used will help you decide how much risk is there with the remaining storage time for your grain. If you used a lot of your allowable storage time while the grain was wet or waiting to be dried or earlier, then you have less allowable storage time left to work with in storage. You want to move or dry grain before it approaches half of the allowable storage time used. Don't plan on using all of that allowable storage. You need to leave some of that for movement of the grain on down this chain beyond your farm. And all other things being equal, if no problems have developed in your grain storage, I would start by marketing the lowest test weight grain first, because that grain is at highest risk for storage problems. In the off-season, when you're not using the aeration fan, it's a good idea to cover the fan. It doesn't have to be a fancy cover, just a tarp wrapped around that opening and tied on there will help. That keeps warm spring air out from under the grain mass, so you're not warming the bottom of the grain, keeping that high humidity warm air out. Also does a little bit to help keep snow and pests out of that plenum underneath the grain bin floor. And a word on safety. Anytime you are monitoring grain, make sure that the grain surface looks right. Before you get into a grain bin, if any grain has been removed, look for that inverted cone as evidence that the grain flowed properly. If there's no evidence that the grain was removed, could indicate that there's a crust over the top and a void space underneath that could collapse and trap you in the bin. It's best to use a partner and a safety harness anytime someone needs to get inside the grain bin, and use proper respiratory protection around dusty or moldy grain. Always stay out of flowing grain, and always lock out and tag out the unloading equipment before anyone enters the grain bin. There are resources available that will help you with a lot of these planning decisions and grain storage and management decisions. The best one available is the Grain Drying, Handling, and Storage Handbook from Midwest Plan Service. This was recently revised. The hard copy is $74. A digital download copy is only $56. And through the end of 2020, Midwest Plan Service is offering a 20% discount on either of those, knowing that a lot of folks have a lot of planning decisions to make this year. There's also a lot of good information available on the post-harvest web pages from the University of Minnesota Extension at the site shown here on the page. And there are some good training modules available from the Iowa Grain Quality Initiative at iowagrain.org. As always, you can contact any of your field ag engineers in Iowa for more advice or if you want to talk about specific situations that you have on your farm. Thanks for joining us. Please give us a call if you have follow-up questions.